All right, so another common redox reaction that we've seen in lab is the reaction between metals and acids. So some acids can dissolve some metals, or you could say that some metals can reduce H+, right? Not all metals, but some of them. In Chem 102, you'll learn about which metals and why. Let's just take a look at an example with magnesium. So magnesium as a solid plus HCl. It has an aqueous solution. Will combine to form magnesium chloride and H2 gas. Which can then obviously leave, right? So this is an example of something that's a gas evolution reaction and a redox reaction. Let's check out the oxidation states. We've got magnesium by itself here. Magnesium by itself is going to be 0. Next up, we've got hydrogen with a nonmetal, so it's going to be +1. Chlorine, halogen, generally -1. And then over here, again, the chlorines remain -1. Except now there's 2 of them, which makes the oxidation state of magnesium +2, which makes sense. That's its normal charge. And then finally, the hydrogen's now in its diatomic state. The oxidation state here is 0. So we can tell the magnesium went from 0 to +2, so it got oxidized. But it is losing those electrons and giving them to something else, so it's reducing something else. So magnesium is the reductant. And then the hydrogen went from +1 to 0, so it underwent reduction. But it took those electrons away from somewhere else, so it oxidized something else, so it's an oxidant. What about the chloride? The chloride, you can see, is just a spectator ion. HCl, again, is a strong acid, so it fully dissociates into solution. So if you wanted to give the net ionic equation, it would just be some magnesium plus 2 H pluses goes to Mg2 plus a hydrogen gas.